So, first of all, a wonderful good afternoon, and welcome to this final and closing keynote. So now, Phil already tried to tell you a little bit about the selection of keynote speakers. You're now probably thinking, whoa, a keynote. Klaus, that's good for you. Great, congratulations. But probably you shouldn't. So let me explain a little bit more about the selection of keynote speakers, the little secrets that Phil does not want to talk about. So, first day, the entry keynote, the opening keynote. That, of course, should be a talk that is just super exciting. Yeah, of course, people should be excited that they are at the conference, and they should be happy that they actually went there. So, exciting, exciting, exciting. And this excitement, of course, carries on into day two. Then on day two, perhaps things slow down a little bit, but this is what the mid keynote is for, to just project this excitement so that people don't want to go to sleep anymore. Yeah, this is also why the dinner is actually on the second date. Yeah, the little secrets. But then comes the third day, the last keynote, the closing keynote. No, you don't want this keynote speaker that is exciting people anymore. No, just the opposite. You want people to go home afterwards. So, here I am. Thank you very much. All right, so Phil already introduced me a little bit. This is me. And yes, he's already said that I've given a couple of talks about software design in the past. And so I don't want to disappoint. I want to talk about software design based a little bit on the book that I've written on that. So I'm going to talk about software design, object-oriented programming, functional programming, probably sneak in a little bit of generic programming too, and of course, I'm going to talk about the big picture. So, for that, in order to get in there, let's just start with my toy example. I know the same example I've used for a couple of years by now. Yeah, you're going to draw a couple of shapes. And I know. At this point, the first couple of people complain, Klaus, please select another example. I will probably, eventually. But I'm after a simple example. So simple that nobody really has to think about the example itself. That should be self-explanatory. But I'm going to throw in a couple of requirements. So first, I eventually want to add more kinds of shapes. So initially it will be circles and squares, but eventually I want to have more. That's a pretty important point. So I want the extensibility of new kinds of shapes. But then, sure, on slides it's always tiny little examples. Please think big. After all, this will be eventually a 10 million lines of code base, and probably 100 developers will work on that, perhaps even more. So that's the kind of scale that we're now talking about. So let's jump in. Let's try to solve this by a first approach to do that. A classic object-oriented solution. So we're going to start with a shape-based class. That one's going to have a drawMember function. Sure, that's the one thing that we're now looking for, but there may be other things as well. And of course, there will be derived classes, like our circle. So circle itself is not particularly interesting. So as a general note, you do not have to read through the entire code. I'll point out the really interesting parts. So of course, a circle has a radius that it stores, maybe other data members, center points, whatever. But eventually, the circle is going to have to draw. This, however, is details that I do not want to implement inside the circle class. I do not want the circle to know about draw behavior. That would be ridiculous. That would be a pretty severe coupling. And so I factor this out. During construction, I'm giving a draw strategy for a circle. And that's this thing up here. So it's a base class again, with a virtual destructor, but also with a pure virtual draw function that allows me to draw a particular shape. In our case, this first will be the circle. So the circle is given this draw strategy, takes ownership, okay, stores it in its data member, and whenever the circle wants to draw itself, it just triggers its strategy. Good, proper design. Now, of course, there's not just circle, there's squares too. Now, A square is pretty much the same thing. And that's just 2, because else it would be repetitive. Imagine I could, of course, be a couple more. So now, of course, we do not want to have just a single shape, one of many shapes. So I'm going to store them in this vector of shape pointers. Sure, that's how we do things. Perhaps a little modernized with a unique pointer to shape. All right, so shapes is this vector of unique pointers of shape, which I do not just create. No. I am throwing in a factory. Sure, this is how we do things. We factor this out too. So this factory will allow others, like you, to create a certain selection of shapes, yeah, with this pure virtual create function. So then I want to draw all those shapes. So I have this function which takes a vector of shapes and just traverses them to draw them. All right. And then I have a create and draw shapes function, takes a factory, takes a file name, and we first create this vector of shapes. Good thing I don't know what this will be. That's part of what the factory does. And then I draw all those shapes. Nice. Good. Now with everything in place to actually do some work, I can now, for instance, draw by means of OpenGL. And if you don't like OpenGL, please pick another library. Doesn't matter. So I have a particular implementation of the strategies for circle and square, potentially a few more. All right. Then there is a constructor which takes all kinds of information that it needs to draw things. I implement the 2 necessary draw functions, and that's it. Good. Factory just the same. This is now a particular implementation of this shapes factory. And again, don't read through all the code. I just implement this create function. I read from the file. I figure out whether a circle or a square needs to be created. And, well, I create it with a make unique. Make unique circle or make unique square. And pass whatever information is required. Good. All right, and I just put it together in the main function. Create a factory, and I call it create and draw shapes. Good. So now, pretty basic example, but of course, where's the design aspect? So let's do the following. Let's split this up. Let's put in an architectural boundary right here. So above this line is what I would call the high level. That's the stable stuff, the things that do not change too often. And below that are all the implementation details. Yeah, how exactly I will draw, which library I use, what exactly I create, so the volatile stuff. Okay, and now you look a little confused. Okay, let's just call it your code and my code. That's simpler. So above the line is my code, below the line is your code, meaning I don't care about the details, but you care about the details. Good. So we can separate concerns. And now you controlling details, you are able to add new stuff. So for instance, a rectangle, which would just implement similar to all the other shape types, but a rectangle has a width and a height, but it would most certainly also get a draw strategy for rectangles. And the rest is pretty much the same, although it's quite some code. You could also easily introduce the according draw function for rectangles. Why not? And you can write the missing piece to also create rectangles from this file. Great. So you can extend by new kinds of shapes. And this could be many. Now, all of you could do that. So I think this would scale quite nicely. Great. So, and there's even something better. Did you notice that this is real modern C++? Oh, you might have not noticed. So, for instance here, unique pointer. And of course also somewhere below a make unique call. A move semantics, override. Haha. Then we have, look here, an equal default. We have an auto keyword, and this in a range-based for loop. And even better, string view, C++17. Whoa, it's amazing, right? A modern C++ solution. Okay, I actually expected a different reaction. Somehow. You look kind of skeptical. And if I take a closer look, some of you have a pretty weird expression on your face. I know what you're thinking. Klaus, is this for real? Is this what you're presenting in a 2024 keynote talk? Don't you have any shame? Okay, now I'm leaving. I want my money back. Okay, don't leave for just now. You might not just get the subtle details of different keynotes, right? Yeah, you want to leave, but you will not get your money back. No. You've literally spent 97% of the conference here already. No. There's no money back at this point anymore. But I totally get your point. I do get it. You're pretty unhappy about this style of programming. And this style of programming has a name. It's based on this book. A book that you've probably seen many times before. You've probably even taken a look into the book. This is what we call the Gang of Four book. Gang of Four because of the four authors. And so based on the book, this style is what we call the Gang of Four style. It's a classic style. Yeah, but let's be honest. You might be unhappy about this. You might feel, oh, this is not what I would write today. But quite honestly, this is what is used out there in pretty much 90%, probably even more, of all code bases. This is the reality out there. You might not believe it, but this is because you're part of this little bubble of the community. Yes, you go to conferences, you watch talks, you might even read books. You know better at this point. But the large crowd of C++ programmers actually does not. And so, of course, the style is still pretty much in. Yeah? It's pretty much present in pretty much all the places. So, that's my first point. If you truly want to change these things, if you want to see modern styles, real modern styles, then it's not just enough that some people get up on stage and talk about this. No. You have to spread the message. You have to go out there. You have to go to the people in your company, in your groups. You have to tell them that there are new approaches. But of course, people on stage have done this before. So you might know this talk, a talk from 2013, so over 10 years ago. Probably one of the most famous ones. Inheritance is the base class of evil. Actually a pretty short talk with just 24 minutes, but a pretty serious one about the fact that this is just not the style we're doing anymore. I have another one. I have to do that. I mean, Phil is the, OO considered harmful, which kind of conveys the same idea. There's apparently something wrong. But also this one, a back to basics talk about object-oriented programming. Now, if you would go to such a talk, you would, of course, expect nice words about object-oriented programming. You would expect that there is, that you're just told how good it is and what amazing problems you can solve with this. But no. Jon actually starts with a slide entitled, "Why are so many developers hating on object-oriented programming?" And pretty much just the following thing. Object-oriented programming is not what the cool kids are doing in C++. They're doing things at compile time. Functional programming. Object-oriented programming, this is so 90s. Okay, yeah, this is what you said. But there's even more. You can be even more negative. Yeah, the title, Object-oriented programming is dead. Long live data-oriented design. And I even found one more, which also I found pretty negative from a title perspective. Eliminate virtual functions. It's not like replace or use something. No, it's eliminate virtual functions. Really negative. Okay, and then last year at cppcon, I got the following review for one of my talks. I believe that object-oriented programming, and especially its theory, is overestimated. C++ has always had templates, and now also has std variant, which makes most of the use of inheritance unnecessary. Of course, std variant. That ought to be a modern solution. So let's just do much better. Let's implement this by means of variant. So, first of all, I'm starting with a circle again, but you notice one thing already. It's much shorter. There's no base class. Oh, too quick. There's no base class. There's no virtual function. This is pretty much the simplest circle that I could present. There's nothing special here. Of course, square is pretty much the same. And imagine, again, there may be several shape types, similar to these two. But then, here. Oh, okay. Circle and square are so much simpler indeed, pretty much what I just said. There's no inheritance. Also, there is no dependency on any graphics code. These two don't know anymore about drawing at all. There are no pointers or base pointers. I don't have to take care of lifetime, so you don't see unique pointers move, etc. And it's just less code to write. So, but then here, stud variant. This is where I now put stud variant to good use. So my variant stores different kinds of shapes. Circle, square, and potentially a few more. So what would be a good name for a thing that abstracts from different kinds of shapes? Well, shape. So that's kind of replacing our base class. Oh, not bad. And there's even something more. I now put variants into the vector, the vector of shapes. That's pretty cool, isn't it? No pointers anymore. Values, just values, which first of all looks so much nicer, but also will be much faster. Okay, then I have a shapes factory. Pretty much the same thing, but no inheritance necessary. Not a bit, not a single virtual function. And, which I also find to be really amazing, I just don't have to allocate anything anymore. I emplace circles, I emplace squares, and that's it. No dynamic memory allocation anywhere. Values, value semantics. All right. And one more opportunity to create a variant, right? So we have a variant of factories. That's what I just shortened to factory. Oh, yeah. Then the drawing functionality, again, no base class necessary, just simple call operators that we'll then use in visit. And yes, of course, one more opportunity to use a variant of the drawers, the different ones. I only have one at this point, but this is the abbreviation called drawer, or abstraction called drawer. All right, and then I draw all the shapes again. Oh, that is pretty cool. Yes, I am using visit with two variants. I'm drawing a certain shape with a certain drawer. Ooh, multi-dispatch. Then I have create and draw shapes again. So again, I am using a variant factory, which creates a vector of shapes, which I then draw with the given drawer. And again, I put everything together in the main function. I know, at this point, this is the reaction I expected. Yes, you're speechless. You don't know what to say. You don't know what to say. That truly is amazing. So, it truly is so much better. There's no inheritance. But it's a much more functional approach. Pretty much functional program. There are no pointers, and especially also smart pointers. They are just values. Values everywhere, which is exactly what we are told on day one in the first talk. This is what we should do. Yay! I don't have to manage graphics code in the shapes, but it's outside. It's probably separated. Single responsibility principle. It's pretty elegant, also from a lifetime management perspective, because it's pretty much automatic storage. Yay! It's less code to write. So much simpler. Seriously. Also, the slides were so much simpler to prepare. And on top of that, better performance. Better performance indeed. Whew, performance. That's the word that on a C++ conference always causes trouble. So if I now talk about performance, afterwards people, as usual, are going to complain about my performance numbers. Yeah, they will argue, but my code is different, and here's fast, and this is slower. Okay. So let's make a deal. I'm going to show a couple of performance numbers, but you're going to promise that you'll not complain afterwards. Okay? So, do you promise? Also the people in the back, please. Yes? Yeah? Because I know what is happening. You leave early, and then quickly after you leave, you write the first email, Klaus, the performance results were weird. No. Okay, all promise? Good. So, first I should explain what I do. 6 different kinds of shapes, which is definitely more realistic than just 2. So I have circles, squares, ellipses, rectangles, hexagons, and pentagons. And please don't expect that I took a lot of time to implement them. That's as simple as possible. Then I'm using 10,000 random shapes, really random, because I do not want any compiler or optimizer or whatever to optimize too aggressively here. Then I run 25,000 translate operations, simple operations, which actually happen to be the same for all the different shape types, which is important. So it doesn't really matter which shapes I create, but still random. Then I benchmark with pretty up-to-date compilers, I believe, GCC 13.2 and Clang 18.1.4. And I'm using this, which is my machine. Okay, so here are the numbers. Classic object-oriented programming, this number. I know, again, this is not a competition between GCC and Clang, yeah? So it's just numbers. If I now replace this with std variant, and okay, now people complain, but Clang is slow. Okay, then this is why I threw in an mpark variant too. Faster, much faster. This is pretty much 50, 60 almost % faster. Wow, amazing, isn't it? Absolutely amazing. So imagine if you now go home and replace all your inheritance hierarchies with std variant. The performance that you will get is you will get a double payment for this year. I promise you. Yeah, I promise you. This is for sure. So this is so good. This is so good that even the ancients have already talked about this. So, one feature to save them all. One feature to enlighten them. One feature to bring them all. And in C++ heaven, bind them. Sounds familiar, right? Yeah, I've read this a long time ago. Whew. It is a great thing, absolutely. Okay, however, it was kind of expected. It definitely was. This is pretty much what all the people tell us to do. Yeah, Jon said, the cool kids, they are doing functional programming. Of course. And he was not the only one. Phil also talked about functional C++. Okay, Phil is the organizer, so I had to present him twice. Okay. But also Kevin Henny talked about this, functional C++. And what Kevin says, that is correct, right? And I even found one more. Also, Victor Chura talked about the imperatives must go. So pretty important people tell us this is how it works today. Okay. So the only thing that is now missing is that we now take a closer look at the architecture. Okay. So back to the code. You're still super happy, I know. But let's draw a line. Okay, let's start simply by drawing a line. Here. So this is my code. Draw shapes and create and draw shapes. This is my code. I guess this is the functions where I just don't want to know about your details. Okay, so if this is my code, this is where I draw the line. My code, your code. If I think about this, this does not feel correct yet. No. If you scroll up a little bit, OpenGL drawer. That is not my code. No. That is your code, of course. You care about the details, I do not. So this and the according abstraction, the drawer, that goes into your code. So just have to shift around the code a little bit. But wait, okay. Drawer. You define the drawer, but I use the drawer. Okay, that is weird. Okay, sorry, this was probably my mistake. Probably the using drawer needs to be my code. But now, wait a second. OpenGLDraw is in your code. I cannot know about this detail yet, right? Oh no, I think this is broken. This doesn't work. It's entirely broken indeed. So seriously, this is an architectural disaster, total failure. We cannot even extend this. All the abstractions are actually, it's not clear who they belong to. And yes, of course, the variant contains all the knowledge about the types. They're not gone, so you cannot add anything anymore. I cannot really add, and I don't want to. This just doesn't work. This is why perhaps the other ancients talked about this a little differently. So, one feature to fool them all, one feature to blind them, one feature to bring them all, and with dependencies, bind them. That was also unexpected. So, however, now you complain and say, but wait, Klaus, no. We're not done yet, you just do it wrong. And this was openly said. Templates and variant, right? Okay, so let's throw in a couple of templates because that is gonna solve the problem, for sure. All right, so I now put templates everywhere where I need to know about your abstraction, right? So that's gonna invert, finally, the dependencies. So draw all shapes is now a function template. So I take a vector of shapes, something. I take a drawer, something. Yes, of course, this is kind of inverting the dependencies. Now, I don't know about your abstraction anymore, and you can own your variant. Create and draw shapes. Well, of course, a template too, because I cannot and I don't want to know about the details. So factory is going to be a template parameter. Drawer is going to be a template parameter. And again, I am inverting the dependencies. And so with this in your code, you can own all these abstractions. You can decide what you want to put in a variant. So shape is on your side. And so are all the other things like shape factory, the GLDrawer, etc. Okay, this looks better. So now, you want a rectangle? You can add that. So you add a rectangle, which is, again, looking pretty simple with width and height, but no inheritance, more value-based. And yes, of course, you can add a rectangle parameter. Sure, you can. This is your code, no problem. In a factory, you can also add the necessary behavior for adding rectangles. And last but not least, for drawing, you can extend this OpenGLDraw quite nicely. Good, it does work. Okay, however, think about this again. This now means that I have to put templates pretty much wherever you want to pass me something. In a bigger code base, 10 million plus lines of code, this now kind of means that pretty much everything is turning into a template. And I'm not sure, and I admit I'm a little skeptical that a 10 million plus line of code base, header only, template only is something that you would like to have. This probably feels also kind of wrong. So, it just doesn't really work. Now, there is no silver bullet. You cannot simply replace one thing with another thing, especially if this is some kinds of abstraction. It does not work. Standard variant is not a replacement for virtual functions. On the contrary, it's the exact opposite. It's the architectural antipode of virtual functions. So it's not a drop-in replacement at all. And so if you just take a look at the properties, variant versus virtual functions, the first difference is that, the first similarity is both are dynamic polymorphism. Okay, I've just seen this in so many abstracts that's very static polymorphism that I thought, I have to put this in here too. But then the differences start. Variant is more a functional approach. Virtual functions belong more in the realm of object-oriented programming. Variant is the thing that you would use if you have a fixed set of types. fixed set, which is not what we need in our case. The virtual functions, however, are more the open set of types. That's what we used. Now we can just derive a new class in order to create a new type. But then, the other way around, standard variant is open for has an open set of operations, whereas object-oriented programming usually has a closed set of operations. Indeed, it's kind of the opposite. Well, architecture and design matter. It really does. However, I kind of feel that this is not what we commonly do. So I believe that the design plays a much more central role than any feature could ever do. And yet, for some reason, these considerations are kind of second of always. So, have you ever heard of a project that failed because somebody couldn't use a feature? Oh, we failed because we could not use structured bindings, concepts. I don't think so. I don't think so. Usually projects fail because the architecture is not correct, because maintainability gets so difficult that people have to rework everything. That's the problem. Now, have you ever worked, and you don't have to answer that, have you ever worked in a project with a real architecture, a real document about that, with architectural decision records that really document exactly why you've taken a certain architectural step? And as I said, you don't have to answer that. I know that few people do that. Few people have a real architectural document. Few people have architectural decision records, which is a shame. And now, just as an example, here at this conference, I counted the talks, I made a survey, and I tried to be fair, but I think only 5 out of 47 talks actually were about software design. Most talks, so the vast majority, always 90%, are about other things. And I don't have the numbers, but I'll leave approximately 50% about the little implementation details, the nifty things, the tricks that we do on the low level. I think in C++, features and language details are definitely in the center of attention. And I feel there is something wrong. We should put so much more effort in the direction of design, that everything works, the big picture, which might be a little harder, but we need that. Yeah, this is, as I said, the reason why projects usually fail. Good. However, I know what you're thinking. Standard variant. I like it and it's so fast. I still want to use it. I never said you should not use it. No. I definitely didn't say that. I just said for this case here, it doesn't work. But you could still use it. But if you do so, then please create an architectural decision record. So write down why you did choose that, so that people later, the next generation of developers, knows who to blame for that. That will help, definitely. All right. But now, the next thing you're thinking is, does this mean we have to go back to object-oriented programming? Really? Okay. Perhaps you've seen this talk. This was a keynote talk at Meeting C++ 2023 by Ivan Kukic, who talked about progressive C++. And in the beginning of the talk, he defined what he means with progressive C++, and he kind of pretended that there is an official statement about what this is, written from somebody in the future. So, Prog C++ is a broad genre of C++. The style was an emergence of psychedelic developers who abandoned standard C with classes traditions in favor of instrumentation and compositional techniques more frequently associated with generic, functional, or value-based object-oriented coding practices. Value-based object-oriented coding practices. Oh, that sounds interesting. But before we take a look at this, there's something else I want to mention. Are you also kind of tired about modern C++? The term? Yes, right? So, do you also feel that after 13 years of modern, you cannot be modern anymore? Yeah, and do you also feel that the term is just misused for anything nowadays? Everything is modern because if it's not modern, it's bad. So I have a suggestion, a new term, but it's not my term. No. Okay. How do you feel about progressive C++? The term that Ivan Kukic mentioned in his talk. I have to admit, I like that. It might not be perfect, but it kind of feels good. I just have to decide whether I want to say prog C++ or progressive C++. Probably in time this will be abbreviated anyway, but I like that. And so now for the remainder, we're doing progressive C++, which definitely sounds much better and truly modern. So, first of all, thank you, Ivan, for finally coming up with a better term. All right, but now let's do progressive C++. A value-based object-oriented solution. So I'm now starting to go back to the first thing that you've seen, this shape-based class and this deriving circle class. And again, the details, just glance over this is enough. Now the first thing I do is, doesn't really look like a valuable thing, but I'm now renaming shape to shape concept. Okay, just a minor change, nothing big, nothing to worry about. But then I am introducing another derived class. In between these two, I am introducing a shape model. Shape model derives from shape concept, but it also has a couple of other really important properties. First, it's a class template. So it's templated on a concrete shape type, which is potentially a circle, a square, rectangle, etc. But also, it owns a shape. And it is initialized by means of one of these shape types. So now this class, this implements draw. But how do we implement draw here? Well, before we actually have factored this out, why not do this again by means of a strategy? But this time, because this class is a template anyway, we could just factor this in by means of a second template parameter, the draw strategy. So we're given a draw strategy, we initialize the data member, and now we know how to draw ourselves without having to know the details. Good. All right, now that we have this shape model class that pretty much can do what the circle can do, we can potentially just simplify the circle. So we just strip circle of everything that has to do with the space class and drawing, which makes it much simpler. That's all we now need. And yes, that's the circle that you've seen before, the circle that we've used with this variant approach. All right, because there's no dependency anymore, I can also move this up. It couldn't be anywhere, so no strong attachment. All right, now, this shape model class, this now pretty much the abstraction that wraps the polymorphic behavior around different kinds of shapes, which also is kind of exactly what the single responsibility principle tells us, but in a way that you might not have seen it before. I really factor out all the virtual functions into a separate class. But at this point, it still is a classic inheritance hierarchy, which you're not going to change. So this little hierarchy, this external hierarchy, I now put this into a class, which I call shape again. This shape class is given a data member, a unique pointer to a shape concept, a base class, a pointer to base, but not a base that everybody must know. No, it's my personal base, my private base, just for internal purposes. All right. So in order to initialize this, I'm going to need a couple of functions in the public section. I, first of all, will need a constructor, a templated constructor that allows me to initialize this shape with a concrete shape and its associated draw strategy. So I say, here's a circle and this is how you draw it. Here's a square, this is how you draw it. Then I draw. This is again using, this is now using this virtual function. So on my pimple, via the base class I call draw, which of course we'll call the real implementation using strategy and all. And then, because it's supposed to be a value, we should also add the necessary other functions. Copy constructors, move constructors, or copy operations, move operations, perhaps a destructor even. A note, I don't show the details, that of course copying might be related to some clone function in the base class. All right, so what you're seeing here, this shape abstraction can pretty much do exactly what we were able to do in the beginning. So this is pretty much what the shape-based class could do. However, it's faster. It's faster since there's not two, but only one. So a single indirection, a single virtual function to draw. Then this is a value. This can be copied, this can be moved, and so it will feel much, much simpler. And it simplifies the surrounding code, as we'll see in a bit. So this is what we refer to as type erasure. And you see, this is not magic. This is simple, relatively simple. Of course, the first time you do this, it might be a little more, but ultimately, it's just the same things, the same base class, a derived class that you would write anyway. You just wrap this with very little extra code that, however, makes everything else so much more pleasant. And so let's look at the surrounding stuff. Circle and square, simple. No virtual functions, no dependencies to anything. This is simple code. Good. Then we have a vector of shape objects. Not pointers anymore, but just objects. Just like we had in the variant approach. Good. Intuitive. Then another opportunity to throw in a type erasure. Stat function. That is now my shape factory. This function contains anything that takes a string view and returns a vector of shapes. So, and then draw all shapes, which is pretty much the same, except that's a nice little detail that you do not call via pointer, but via value, shape dot draw, value syntax, value semantics. Then create and draw shapes, almost the same, yeah, but no pointers, no base classes. This is pretty much free of any anything that we've seen before. OpenGL drawer, well, again, no base class, but values with call operators that are not virtual. Simple. The shapes factory, again, no inheritance, values. And again, I'm not creating via make unique, but I create values. Values everywhere. Nice. Okay, and then again, I put everything together. Pretty nice. But now again, let's take a look at architectural considerations. So let's again draw a line. Let's draw a line here. Again, above is my code, below is your code. I care about using stuff, you care about the details, how to implement stuff. So obviously, OpenGL drawer is on your turf, your stuff. Shapes factory too. But then again, you can add new stuff. You can, for instance, introduce rectangle. Again, I don't care about this, you do. Then this OpenGL drawer, well, that's your implementation. So please feel free to add the according functionality. You can do this easily. And the same for the shapes factory. Just the same. If you want rectangle, you can add this. It's your code, I don't care. So again, easy extension by means of a new type. Great. So I personally feel this solution is amazing. It really is. It has all the properties that we need and potentially more. So changes extensions work just as expected. You can add what you need. I don't have to worry about that. There is a real proper architecture here. The architecture boundaries are also adhered to. There are fewer pointers, way fewer pointers. Actually, I hope there was not a single one. Less inheritance. Again, very little outside, but inside, of course, there was one inheritance. Few virtual functions. Yes, again, internally there was one, but not outside, therefore simple. and has way less memory management. No unique pointers, no shared pointers. We don't need that. And again, perhaps as a little extra, this might have better performance. Okay, now I've said it again. Okay, just to be sure, yeah, not that you think that your promise only counts for the first thing. Okay, so if I now show you performance results again, do you again promise not to complain? No. Okay. There are certain people that are just too tough to work with. Okay, I'll have to risk it. So this is what I've shown you before, but now I throw in type erasure. So on my system, same example, I get this. Okay, you're immediately saying, but this is not as fast as variant. I never said that, but you do see that it actually is faster than the original solution. And if you now throw in a little bit of optimization, which we could do now because we have a value, not just a pointer, it might be even a little faster. So, okay, not as such a big gain as before, but still, it's cleaner and faster, which is exactly what we need. So, you're now thinking, Klaus, I think you have a pointer. This is nice, this looks good, but does this now mean that we should always use value-based object-oriented programming? Well, of course not really. Please also use function programming capabilities, which makes you think, but then when should I use functional and object-oriented programming? Okay, and this is the answer that you probably don't want to hear. Of course, it depends. This is the proper answer that you'll probably always get. It depends. But I could perhaps give a little bit of guidance here as well. So, the variant, okay, as I said before, that's more the functional style. Type erasure is more the object-oriented style, the value-based object-oriented style. Variant, you use that if you have a fixed set of types. Type erasure is the thing that you use if you have an open set of type. And vice versa. If you know that you want to extend operations primarily, then variant is your thing. If you have a fixed set of operations, then perhaps you're over here. But then I would say that functional programming itself is very, very nice on the lower levels of an architecture. In the implementation details. This is why so many people talk about algorithms. This is the lower level. This is where it really works well, fantastically, I would say. And this simplifies the little details, the implementation details. But the higher you go in an architecture, perhaps the less valuable it might be. Perhaps this is where you start to use more high-level, more object-oriented abstractions, the value-based one. All right. So I would argue these two are just the same thing, but on opposite sides of the same coin. So perhaps on this side, you could say this is the object-oriented programming side with type erasure. On the other side is the functional programming stuff with variant. But now what I'm not saying is that you just flip the coin and pick whatever the coin tells you to do. No. Exactly not. You pick the side that's best for your problem. So the first rule of software design, I would say, is think about the architecture properties of a solution first. So it's not about pick the fastest solution first and then later suffer from a lot of dependencies. Think about the architectural properties first. Now, I might say that because I kind of anticipate that perhaps in a year, perhaps in 2 years, we'll have a lot of talks that tell us to do everything in one particular thing. So this is again a keynote talk from Andrei Alexandrescu, who at Meeting C++ in 2018 talked about the next big thing, which he said is, of course, reflection. I'm gonna expect that once this hits us, potentially in 26, everybody's like, whoa, let's use reflections everywhere. No, please don't. First, think about the architectural properties and advise people when it is appropriate and when it is not. Because this ultimately is the second thing to consider. So please consider both advantages and disadvantages of a solution. Unfortunately, I see too many talks where people just say, well, this is great, use that. but nobody tells me when not to use it. So when you do a talk, when you explain something to colleagues, whenever, consider both sides, please. Okay, so there is no silver bullet. You will always have to decide. And I don't say this is easy. This is tough. This is our job. And we enjoy it after all, a little bit at least. So always consider pros and cons, please. And of course, it always depends. That's pretty much the final answer. So thank you very much.